Hi, my name is Skip Marsh, Senior Solutions Architect with Silk, and I'll be reviewing the Flex interface. Flex is the orchestration engine and resource manager for all Silk resources that make up Silk data pods, and I'll review how it is leveraged and used. On the left-hand side of the interface, we show some high-level detail around the cluster itself. So Flex is deployed out of the marketplace, and Silk provides a cluster configuration file, sort of a licensing file, if you will, for customers. Once you receive that during the deployment, we create the cluster from those pieces of information. That information consists primarily of address space, but we also add additional details for call home, etc. You don't change any of this generally after deployment, but we do leverage these pieces of information for the default settings on the creation of data. The rest of the interface, the center portion of the page is where you will see your data pods as you create them. They will stack up in a line in there. The top of the page shows you how many data pods and the resources that are being used in the environment, as well as aggregate details around performance and capacity. Over on the right hand side, there's a little arrow there that you can either hide or show. The activity tab shows the history of activity that's occurred within the platform. Pretty good resource to leverage. There's a banner in the middle of the page when you don't have any data pods, and then if you've got running data pods, if you want to create another data pod, you'll use the sub tab over below the performance metric detail. And then if you have existing data pods running and you want to add resources to them, you use the manage nodes option. I don't have any in this demo, but you would see if you had data pods, you could add C nodes to an existing data pod, and you can also add M nodes to existing data pods. This is the interface you would use for that. To create a data pod, you click Create Data Pod option. We bring in the defaults from the cluster configuration. We need to give it a name. Use some sort of an effective name so that when you have multiple data pods, you can quickly determine which data pod is running the services that you wish to leverage when you're logging into them. Just give it a name, go to the next, because I'm not going to change any of the defaults, but you could put in different passwords, etc. This is the page where you do most of the decision making around the creation of a data pod. We do support all three clouds, and I'll focus on the right hand side here first. Default for deployment in all three clouds is leveraging VMs for the M nodes, which are depicted down here on the left hand side in the lower quadrant. In the Azure cloud, however, we are also able to leverage Premium V2 for the M node capacity. If you'll notice when I select that, the sizes of the M nodes, there are more sizes available from 5 TB to 80 TB. When leveraging the VM-based M nodes, this is a lab environment, so you won't see this very small option in the other clouds, but you'll see different size M nodes depending upon the cloud provider. They deploy in different sizes as well. I'm just going to focus on the L series for this example, but for PV2 in the Azure cloud, you can deploy with a different performance and relates to IOPS, and that's per C node. Typically, we see most of our customers deploy with 80,000, and performance is our brand, and even at 80,000, the system is much slower than you would see run in L series. Although we do have a way to address that through cache acceleration. This is a very large cache in the tens of terabytes, depending upon how many C nodes you have deployed and which cloud it's deployed in. The Azure cloud, we have 15 terabytes of cache per C node, and each C node is responsible for a certain portion of the address space, so it is a true scale-out cache. and the read performance off of that cache is as fast as anything you can do in the cloud. Typically, that's under 200 microseconds response time from the data pod back to the application, so extremely high performant, but the maximum throughput with read cache enabled is lower than it would be with non-read cache in the environment. So I'll focus on just what you would do in all three clouds and VM-based deployment, no caching enabled. Once you've made the determination of what type of resource you want, the next big consideration is capacity. This capacity at the logical limit is not configurable or editable after you deploy the data pod. You can scale physical capacity, but you can't scale logical capacity. Logical capacity is a relationship to the number of C nodes as well. So if I hover over the 256 TIB option, that needs a minimum of 3 C nodes. If you want a larger scalable architecture, you would need to go up to 4 C nodes, 5, 6, etc. You can scale up to 8 C nodes on a data pod for performance reasons, or getting your logical capacity to where you expect the upper end of a data pod's capacity requirements to be. Keep in mind the logical capacity is something that is taking into consideration data reduction. So if you say you're getting 4-to-1 data reduction, every 4 terabytes of logical capacity only takes up 1 terabyte of physical capacity. So keep in mind we're not really focused on the physical, because we can scale the physical as need be, but we cannot scale the logical. Once you've made your determination there, you need to get the C node count to meet the capacity limit requirement, and then you need to add an M node. You can see our error over here in the upper right says we don't have enough M nodes or C nodes to create the data pod. I don't have any M nodes selected, so I'll select one. We'll also give you warning we're checking your quota for resource availability. So if I add too much here, I know that when I add an 878 terabyte M node, that I exceed my CPU quota for the standard LSV3 family of VM CPU type, and I've exceeded that by 40, so I would need to go increase my quota to provision that data pod. Once you've made your selection, you click the next button. That will kick off the creation of the VMs required to deploy this data pod. You'll see the activity depicting that information over on the right, and about 25 minutes later, I'm not going to create one at this time, but 25 minutes later you'll see your first data pod here, and there'll be a separate video discussing data pod administration.